Okay, in previous lessons we learned about solving systems of equations with substitution, and now we are going to learn another way with it, which is elimination. What you want to do in elimination is you want to get your two linear equations, and again I can tell there's linear because there's no more than two variables. They are not multiplied together. There's no variables in the denominator, and there's no exponents or radicals or anything like that. So I do know that these are linear. I could get them into y equals mx plus b, no problem, which is a big hint that they are linear. Anyways, with elimination, what you want to do is you want to get your variables lined up on top of each other. So you want the x's on top of the x's, the y's on top of the y's, and the constants on top of the constants, which in this case they are right here. Then your goal is to be able to add these two equations together to get one of your variables to drop out. And the way you're going to get it to drop out is to make them add up to 0. Okay? So right now, when I add my two equations together, if I add 3x and 2x, I get 5x. That means my x's did not drop out. I still have some x's there, okay? But if I add my negative 5y and my positive 5y, that does make 0. Notice one is negative, one is positive of the same variable, same value, okay? Those drop out, and then on the other side, I have negative 16 plus 31, which I will add to make 15, okay? Now I want you to notice how you only have one variable left in there, which is x. And you can solve for x no problem. If I want to solve the equation 5x equals 15, I would divide by 5, and I would have x equals 3. Okay, now I've got one variable, but in my original equations I had two variables. I had some x's and some y's. And so now what you need to do is you need to take that x value, which we now know is 3, and I need to substitute it back into either equation. It makes absolutely no difference which equation you substitute it back into. I will just take it and stick it into that top one right there. And so I will take this equation now, and I could have used the other one also, it doesn't matter, but I'm going to take that x and I will replace it with 3. So I have 3 times x, which we know is 3, minus 5y equals negative 16. So I have 9 minus 5y equals negative 16. Subtract 9. And I have negative 5y equals negative 25. Divide by negative 5. And y is 5. And again, I want your answer as a coordinate and an x, y, comma, coordinate. So actually your grand final answer, your x value is 3. Your y value is 5. This right here is actually your final answer, how I want it written. What that means is that this system of equations has one solution, which is 3, 5, which means that those two lines intersect in one spot, which happens to be the point 3, 5. All right, here's another one. If I were to take these two equations now and add them together, if I add 3x plus 5x, I get 8x. And if I add 4y plus 2y, I get 6y. And that means I still have some x's and some y's left. So sometimes what you need to do is you need to multiply one or both of the equations by a quantity so that you can get them to drop out. So for instance, in this case it's going to be easiest to get my y's to drop out. If I want them to drop out, if I have 4y on the top, I need to have negative 4y on the bottom so that they can drop out, okay? So 4y plus negative 4y makes 0y. So I need to think about what can I multiply my bottom equation by to turn that 2y into negative 4y so that it cancels out with the 4y in the top equation. And I would want to multiply that bottom equation by negative 2. When you do that, you need to multiply the whole entire equation by negative 2, okay? So I am going to move this down, actually. I am not going to touch the top equation. The top equation is just going to stay at 3x plus 4y equals 6. But the bottom equation, I need to distribute this negative 2 all the way through that equation. So negative 2 times 5x is negative 10x. Negative 2 times 2y is negative 4y. Negative 2 times negative 4 is 8. Okay, now when you multiply those or add those two equations together, if you add your x's, you have negative 3x, or positive 3x plus negative 10x, which makes negative 7x. When I add my y's, 4y plus negative 4y makes 0. Those drop, and then 6 plus 8 makes 14. Now I've only got one variable in there, which are the x's, and it makes it much easier to solve. So I will now divide by negative 7, and I have x equals negative 2. So I'm partway there. Then I need to solve for either x or I'm sorry, I've got it solved for x, but I need to solve for y, and I can do that by substituting that x value into either equation. Makes absolutely no difference. I will take it and plug it in up to the top one. So I will have 3 times negative 2 plus 4y equals 6. So I have negative 6 plus 4y equals 6. Add 6. So 4y equals 12. Divide both sides by 4. And y equals 3. Okay. But again, a reminder that I want your answer as an xy coordinate. So negative 2, 3 is the solution to this problem, which means I've got the two lines that happen to intersect in one spot, and that spot is negative 2, 3. And you can see that on the graph. All right, then sometimes what happens is you need to multiply both equations by something. So like to get my x's to drop out, if the bottom equation is 6x, the top equation would have to be negative 6x. And there is not a whole number that I can multiply 4 by to get it to be negative 6. And we don't want to deal with fractions. Fractions are gross and ugly and icky. And you don't have to deal with fractions. The easier thing to do would be able to figure out how to multiply both equations by something so that either the x's or the y's drop out. They don't both need to drop out. Either the x's or the y's do. Okay? So in this case, if you want the x's to drop out and you think about 4 and 6, 4x and 6x, 4 and 6 both go into 12. Okay? So let's figure out what we have to multiply the top equation by to make it be 12x. Well, 4x times 3 is going to give me 12x. Okay, so I'm going to start with just the top equation. I will distribute this 3 through. So 3x times 4x becomes 12x. 3 times 7y becomes 21y. 3 times 6 becomes 18. Okay, now if I'm trying to get my x's to drop out, if the top equation has positive 12x, the bottom equation needs to have negative 12x. So I have 6x right now, and you need to think about how can I get from 6x to negative 12x. And to do that, I would multiply by negative 2. So negative 2 times 6x is negative 12x. Negative 2 times 5y is negative 10y. Negative 2 times 20 is negative 40. Okay, now add your two equations together. 12x and negative 12x makes 0. 21y minus 10y makes 11y. And 18 minus 40 makes negative 22. Okay, divide by 11. And y equals negative 2. Not done. I need to take that and I need to replace it into really any one of my equations. I could replace it into my black ones too, it doesn't matter. But I will plug it in right there. Okay, so now I will have 4x plus 7 times, I know my y value is negative 2, equals 6. So I have 4x minus 14 equals 6. Add 14. So I have 4x equals 20. Divide by 4, and I get x equals 5. Okay, so my final answer would be x, which is 5, y, which is negative 2. And again, that means that these two lines intersect in one spot at the point 5, negative 2. So there's one solution to this system. All right, last one. here, let's get, it doesn't matter if we want our x's or our y's to drop out. Let's get our x's to drop out. So 4 and 3 both go into 12. So I will multiply this top equation here by 4. Okay, so the top equation, when I distribute that 4 through, 4 times 3x is 12x. 4 times 6y is 24y. 4 times 9 is 36. Okay? Now, if I'm trying to get my x's to drop out, if the top is 12x, I need the bottom to be negative 12x. So I have 4x right now, which means I would need to multiply by negative 3 to make that bottom be negative 12x. So negative 3 times 4x is negative 12x. Negative 3 times 8y is negative 24y. Negative 3 times 12 is negative 36. Okay? Now when we add our equations together, this is what happens. My x's drop. 24 plus negative 24y is 0. So what I have left on the left side is 0. Equals 36 minus 36 is 0. When I add 36 and negative 36, I also get 0. So all you get is 0 equals 0, okay? Just like always, when all of your variables or your letters drop out, you have two choices. Your choices are either no solution or all real numbers. When you're left with a true statement like this, 0 equals 0 is a true statement, 0 always equals 0, then your answer is all real numbers. Which in this case, when you do all real numbers when you're solving systems, it means that they're the same line. Okay? If you got to the point, let's say, separate problem, okay? And let's say you got to the point where you had this. 12x plus 4y equals 20, and negative 12x minus 4y equals 10, okay? Let's say you were at this point in the equation. Well, you would add your x's together, they'd drop. You would add your y's together, they would drop. So what you have on the left side is 0, but what you have on the right side is 30. Well, 0 doesn't equal 30. Okay, it is not a true statement, so then your answer would be no solution, which means that they are parallel lines. Okay, just so you know.